Hello everyone, so welcome back to my channel. Today is the day 4 of English speaking practice. So today we are going to talk about a topic that is a data structure basically, that is array. So we study this data type in our programming, and array is basically we can say that it is not a user defined, it is already predefined, but we have upgraded it. Like, if we go on definition of an array, then an array is a collection of similar data items. We can Similar data item means it is a data type. Array is a data type which is used to store data item. They can be any, means multiple data items, but the items must be of similar type. Like, they can be of integer type, float type, any type, character type. They can be boolean or anything. And a special thing about array is that the elements are stored at contiguous memory locations, and the elements of an array can be accessed by using the indices of the array. Means, the in array we define, we give a number, that is known as index, to every element. And like, first element is given the index 0, so indices start from 0 up to nth element, and index of nth element is n minus 1. Index of nth element is n minus 1. So element so let me talk some other things, like, what we can do with array. So basically, we can store element in array during initialization, or we can take it from users. An array of characters is known as a string. Mm, if we want to get, if we want to access an element, a particular element of an array, then we can do using, basically, it we can do it by using, we can do it by using index of the array. So we have what we want. If we want to search some element, some particular element in an array, so there are multiple techniques of searching. So today we'll be going to talk about two techniques, that are binary search and linear search. So in case of linear search, the array is traversed sequentially, and the required element is matched with every element. If the required element matches with any of the element while traversing the array, then the index of that element is returned. If element is not found in the array, then we return -1. And if we talk about time complexity of linear search, then it is, as we are transversing linearly, so time complexity of linear search is on, means it's linear, it is directly proportional to n. So let us talk about binary search. In this, it is also it is a method of searching a particular element in an array. Like, in this method, we repeatedly target the center element of array, and we compare that the center element with the required element of the array. If the required element of the array, or if the required element is less than the center element, then we found the element in the left subarray, otherwise in the right subarray. We repeat this process until the element is found. And in this also, the if the element is found in the array, then index of that element is returned, otherwise -1 is returned. If we talk about time complexity of binary search algorithm, then it is O log n, because, like, we are reducing our steps, like we have an array of n elements. So after one iteration, we reduces the number of elements by 2, so it becomes n by 2. And in second iteration the number of element become n by 2 divided by 2, that is n by 4. And let us suppose that the element is found after k iterations. So after k iteration the element should become 1 if we consider the worst case, because in time complexity we consider the upper bound, that is the worst case. We always take the worst case because another cases will lie under that. So time complexity in that case is 2 n by 2 raised to power k, because in every step the element got half and we repeated this k times. n n so n upon 2 raised to power k is equal to 1, because at last the element become equal to 1 and that is the required element. So when we cross multiply, n is equal to 2k, taking log, when we take log base 2 on both sides, it become n is equal to 2k, log n is equal to k log 2 base 2, and that will be 1. So mm, n will be n is equal to 2 raised to power k, so k will become log n base 2. So that is the time complexity of binary search. Let us talk about sorting the array. What is sorting? Sorting is a method, sorting is a technique in which we arrange the elements of an array in a particular order. They can be in increasing order, decreasing order, or any other order as required. We generally consider it ascending sorting of array. So there are multiple techniques in which we can sort an array. So we will basically talk about three type of sorting here, and these are bubble sort, insertion sort, and selection sort. So what is bubble sort? Bubble sort is a method of sorting an array in which we start from first element of array and compare, in which we starts from the beginning of array and compare the adjacent elements of array. And if we swap them, swap means to exchange the position, like one goes to another position and that element goes to the position from where the element was gone. So if the element are in wrong order, we swap the elements, adjacent elements, after comparing them. This process is followed until the array is fully sorted. So let me talk about second method of our sorting, that is insertion sort. Insertion, in case of insertion sort, we it is like a playing, like we play cards. When we have cards in our hand, we arrange them, like arranging the cards we can compare with an insertion sort. like we like we divide the array into two parts, sorted subarray and unsorted subarray. From unsorted subarray we place the element into sorted subarray. Like we firstly consider one element and then place it into sorted subarray, so that is single element, so it will be sorted for itself, so that is placed in sorted subarray. So next, from unsorted subarray we take this first element and compare it with the sorted element, sorted array uh, sorted array's element. If it is less than, then it come before it, and similarly this process is followed till the array gets sorted. So let me talk about third technique of sorting, that is selection sort. In this method, this is in this method we basically find the greatest or greatest or lowest element depending upon in which order we want to sort the array. Like if in ascending order we want to sort the array, then we find the minimum element of the array and place it at the first position. After that we find the second minimum element and place it at after the minimum element. In this way we repeat this process until the array is fully sorted. So if we talk about which method of sorting is more fruitful, like which method we can use, which method is most fruitful, means which method is easy and faster in terms of complexity. So in bubble sort we compare adjacent element, and that is a like slow technique maybe. In insertion sort we insert the element from one place to another, and in selection sort we find the lowest or greatest element depending upon the order in which we want to sort. So the complexity of a bubble sort is maybe proportional to n square, because n square, no, n square we can say that it is n multiplied by n into n minus I minus 1. So it is basically n is to power 3 by 2 close to 2. And insertion sort and selection sort the complexity is n. So overall we can say that we can't, like, we can compare, but I don't know what's the which method of sorting is good and best. I will be surely searching about this thing and will surely tell this about in another video. So till then, bye bye, that's all for this video. Bye bye.